And welcome to the Desk Ladyada.
Hey everybody, and a happy Daylight Saving Sunday to all y'all. If you're not watching the Grammys, you're here with us, Desk Ladyada. We're doing some engineering, and sometimes we do sing, although I don't think I'd win a Grammy for my singing. That said, we do have some discounts going on right now. If you want to pick up some components, maybe a Raspberry Pi for Pi Day for a song and a half, we've got a 10% off discount code. Use the code PIDAY. It's running until the end of today. I think after that, it's off. It's
so you have 2 hours.
You have a couple hours.
Yeah.
Pi Day.
And celebrating Pi Day, let's just jump right in because this is on my screen. How is this possible?
The head of Eben, I know. Well, this is a little demo for the Raspberry Pi Pico, the RP2040. This is the nightmare. The RP2040 chip. We actually, don't forget, Digi-Key had a live stream today with Samantha from the Pi Foundation, Sean from Digi-Key, Mike from Make, JP, and this Kirk from SparkFun, CTO. And they talked about the RP2040, and I put together a DVI breakout. So you want to pop over to the overhead real fast, and I'll show what the magic is. So this is the RP2040 Pico board, and connecting to 4 sets of wires. We've got clock, TX0, TX1, TX2, so 3 differential pairs and 1 differential clock, with plenty of grounds in between to this DVI breakout. And it's HDMI, but like we call it DVI probably just because we don't have to pay the HDMI licensing fee. So it's a DVI breakout, and all it does is basically give you those pins in a row so that you can use this, standard connector. If I unplug this, will it break everything?
Let's see what happens when you unplug it. It'll be super fun.
And then we'll Dink donk.
Nothing.
Okay, it's gone.
It's the nothingness.
So it's got that standard connector that y'all know and love, and when you plug it in, you get DVI output. And I think they got up to 4K or something, or 2K video. I don't think they have audio going over the video, but the audio you can do separately over I2C. This is a little breakout I put together, and it works fine. More proof that people always say you have to be really careful with your routing with DVI and stuff. I'm like, well, you can actually do it on a solderless breadboard, which is a crime. But differential signals are very durable. They'll put up with a lot of abuse. So this works great, and I think it would be fun. People could get video games going on a RP2040, maybe wire up a Wii controller or a SNES controller and maybe play some arcade games or emulators. It's just fun that you can do this all on a Cortex M0 using PIO. How fun is that? Super fun.
Yeah, and I think, sometimes so the maker and hobbyist community, we're the ones that are pushing the boundaries. We're overclocking. We're doing all sorts of stuff. And I think everyone should celebrate that.
Yeah.
And not be don't do that, police. Be the...
This is hacky.
Cool. You want cool hacky stuff, because all the cool hacky stuff is what pushes the state of the art. That's what we're trying to do here.
It's cool. It's hacky. It's cool and hacky. So I thought, this is neat. I'm going to have this breakout, because I thought it was actually really useful. There's always times when I need to do DVI, HDMI stuff. But I'm also thinking now maybe making a FeatherWing for the RP High, for the RP2040 Feather, so you could plug it in and get maybe I2C audio out and HDMI, DVI out, and then maybe an edge connector for connecting a nunchucky board. I don't know. I'm still thinking about it, but that's my first demo. This is DVI breakout. Thank you for that. I'm going to unplug this. Okay.
Yeah.
So
it did nothing. Everything worked out.
Yeah, I just want to make sure. Okay, so I'm going to toss the cable over there. So that's demo number 1. Second, we talked, I think a week or 2 ago, about mechanical keys. So I think I showed off, this is a Kailh key with a small keycap. It's a mechanical key. And there are these cool sockets you can get. I made a breakout for a socket. Let me see. Can I zoom in on this one? No, I have to actually manually move it, huh? Did it come out?
Okay, do it again.
Do it again? Okay.
Yeah.
You can do it.
No. Yeah.
Okay, whatever. So this little breakout, this is a socket for one of the switches, and if you put the holes in the right location, this switch clicks in. So you can see here profile, and then this is the switch going into the PCB, and it goes through the PCB and into the socket, and so it clips into these 2 pins, and then you can see the positioning hole in the center. It actually works pretty well. There's also a slot in this switch for an LED. You can use like a through-hole LED if it goes all the way up, or if it's very small, like a 1.8 millimeter LED. Or you can use an RGB LED. So remember I talked about those through-hole, sorry, not through-hole, they're surface mount, reverse mount NeoPixels. So I did that. The only thing is I, of course, got the reverse mount upside down, right? Like I didn't flip the pins properly to do the reverse mount. So I did fix it on this little breakout over here by, well, you know, just being a little creative, but works fine. So this is the breakout showing like the NeoPixel you see sticking up here. And then when you attach the switch, it comes out through and illuminates the keycap. I did make this a little bit bigger. Right now it's exactly the same size as a key, but it turns out you can't connect to these headers over here because the switch is like in the way. So I extended this out by 0.1 inch just to give it a little bit more height. So it doesn't tile perfectly on the 0.75 inch boundary, but it's a trade-off. It's just a little breakout. It's meant to make it really easy to use mechanical keycaps. And I also, so I'm going to go back out. I also designed a FeatherWing. So the FeatherWing holds 2 keys. So I'll show that. There's 2 switches, 2 NeoPixels, and you can, you know, that's just connected directly to like 2 GPIO pins for the switches, and then 1 GPIO pin for the NeoPixel. It's really simple. There's no like GPIO expander or assistant or whatever. It's just like literally two switches, but you can cut these traces and rewire them however you like. That'd be kind of fun. So that's that. And then this switch goes here, and I'll show you what it looks like. So I just wired this up, so this switch is basically mimicking this one. It's on the same GPIO. So there you go. And then, hold on. Did I do something wrong? Uh-oh. Uh-oh. I think I uploaded the wrong code to it. Oh, no, it's offset by 1. Oh, sorry about that. Okay. Now we're talking. Okay, so this switch, I have like, you know, it's connected the same GPIO as this one, so you can see the NeoPixel shining through. It's really bright, but it's shining up, and it's, you know, way washed out on the overhead. But here, you know, it's kind of illuminating the bottom half of the key. I will say it's not an even illumination. I kind of wish it was, but I think that's just like part of the bargain. I don't know why. Did I mess this all up? Hold on, let me reset this, just in case. No, weird. I don't know, maybe I uploaded the wrong example code or something. But anyways, I got 2 switches, and normally each one lights up, but I don't know, my demo stopped working. But it still shows like, you know, you get 2 keys and the LEDs coming through. So all I have to do is on these, I'm going to just swap those NeoPixels again, fix the reverseness of them. I also added a Stemma QT connector on one end. There's a little spot here, and JP was like, hey, can you put a Stemma QT on there? I was like, yeah, that's a good idea. So I did that. So those got ordered as well.
All right.
Okay. Well, that was so weird. What did I do wrong here? Oh, well, we'll never find out. Tragic. Okay, but it usually does work. Great, so that's demo number 2. Then the third thing I got is it's Stemma Sunday. I put together this TCA 4307. So this is an interesting, it's a hot swap I2C controller, so it's perfect for Stemma QT because you put your I2C controller here in the peripheral on this side, and what it does is it doesn't connect them until like they're both synchronized up, and there's no like jitter. Like sometimes if you hot plug, the charging of the SCL line on the peripheral will cause it to kind of stay low for a bit, which means all of your I2C gets desynchronized because your clocks have to be like whatever 9 clocks per transaction or whatever number of clocks, and if you're off by 1, like everything gets kind of like messed up. So this is why normally I don't recommend hot swapping I2C, or if you do, just realize that there's a risk that when you connect a cold device into an active I2C controller, the peripheral will cause it to hang. So I was going to show a demo. This I definitely don't know if it's going to work, because the thing is that, once you have the controller running and the peripheral charged, it doesn't do the hanging thing anymore, but let's try it. So I've got my I2C scanner going on here. You can see it's testing each one. So let me see if I can make this hang. No, see, this is the thing. It's not going to hang because I'm doing a live demo. No. I'll try one more time. Otherwise, you're just going to believe me that, like, it broke like 15 times when I wanted to break, it doesn't break. Let me see.
Well, you get a number to light up.
Huh?
You get a number to
Well,
light up.
it's supposed to hang. It's not going to do it. Usually, when I'm not on camera, if I plug it in, it actually like faults. It stops because the I2C gets into a bad loop because it's the SCL line got triggered low. The problem is that once you've plugged in a peripheral, which I plugged in a bunch of these earlier, once you plug it in, it charges up the capacitor on the SCL line on the peripheral, and so you're not going to get that hang effect. Oh, there you go. Ha! I knew it. So you see, it stopped. It hung because I finally found one that was like truly cold. So the capacitor was completely zeroed out, and then that charging caused a glitch. And so the scanner actually stopped, which it shouldn't have, right? It should have just said like that address 45 wasn't found, or it was. Maybe that's the address this is on, 44. Maybe if you just plug it in exactly the wrong time while it's trying to get a response, so you can get the I2C controller to crash. So the neat thing about the TCA 4307 is that it doesn't ever happen when you have it plugged in, because it doesn't connect both sides of the bus until both sides are prepared and you're not like in the middle of a transaction, and then it will join them together for you. So like people who've done this know exactly what I'm talking about. If you haven't, like, just hot swap I2C devices and eventually it'll cause this crash. You'll be like, why is it crashing? That's why. And this is the chip you could use to fix it. So there you go. So that's my demo. I'm glad I finally got it to not work. That's how demos go. The ones that are not supposed to work, and the ones that are supposed to work don't. That's engineering. Okay, and then finally, before we head into the great search, we do have a super secret. It's not out yet.
Yeah, this is world premiere.
World premiere.
We're showing something that no one's ever seen before.
Shh.
What's going on?
Don't tell anyone. Yes, actually tell everybody. So this is under embargo, but we got permission to talk about it. So Digi-Key has a new service that they're adding. It's called the part tracing for cut tape. And so let's go to the overhead and I'll show what it is. So chances are you're used to getting, this is some cut tape 0402s or something, or maybe 0201s. And you're like, yeah, like I know these. This is cut tape. Cut tape, got your parts, peel them off. But what you don't have is on the back of the cut tape printing. So let me get like real down here. And let me. Okay, that's pretty good, right? Okay, you can see it. So on the back, you can have custom printing.
I think you can focus. Maybe make that level.
Oh yeah.
Yeah, and then let it focus.
It's curved.
Yeah, now okay. Now you're good.
Oh, super crisp. Okay, so you can put date codes, lot codes, country of origin, manufacturer, sales order number, purchase order number, and your own component ID. So, you can say, if this is your component ID, or is this your number 111? You can say how many there were. You can say what it is. Okay, so that you have like 0201s, you are never going to know what it is. Like if you lose the bag it came in, there's no markings. Even like 0603s sometimes don't have markings. Sometimes actually 0805s. I've had 0805s that don't have markings, depending on who you're getting them from. And then capacitors, yeah, you're definitely out of luck. So what's neat about this is that on the tape itself, it'll tell you what it is. Great for if you're doing outsourced manufacturing, or even if you're just doing like your own in-house manufacturing, and you get these blasted 0201s where you're like, it's like dust. It actually looks like a mistake. It's like, oh no, they forgot the resistors. No, they're there. They're just really small. So I got sent 2 examples of it, and so we'll try this out too. And then for those who are interested, let's go to the computer, and I'll show you where you can find info. That's secret. Go to digikey.com/n/resources/part tracing. Part-tracing is the, maybe I'll make this, I don't know if, no, I can't make this part big. But you can add tracing ID. Here's the stuff you can add. And there's some information you have to, looks like they're printing on all eligible cut tape automatically. So it doesn't look like it's free. Wow, cool. All right, even better. So free service, it comes automatically. I guess you don't have to opt in, but not all parts are going to have this to start. So it's definitely going to take, it's going to be for like fiber paper backed cut tape to start, because those are the easiest to print on. Like if you have those big plastic ones, those are not going to have it because it's harder to print on them. But maybe they can start with all the 0201s or 402s, capacitors, and inductors, like the toughest ones, and then eventually they can maybe move up. So this is kind of neat, like maybe the machine that normally does the counting and cutting will also do the printing. So it's a kind of neat thing. They said they were working on this for like over a year and a half. So it's finally launching, and I guess it'll be public on Monday. I ordered some cut tape, so I don't know. Maybe we'll see if the cut tape order comes with some printing on the back.
Yeah, Monday's in a few hours. We'll see.
Okay. Let's see.
Worldwide premiere.
Let's see, 8mm paper carrier tape with at least 8 inches. So you have to do the math. But check out more info. To be honest, I did not. I just got these like on Friday, and I was like, gonna check this out. So this is all new to me, but this is really neat. I think I will definitely use this because I have those little tweezers, and like I have to, when I have cut tape, I have to check the values. It'd be much nicer if I actually just had the values printed on the back. And I think most people who deal with small parts will agree. So
Okay.
check that out.
Premiere.
Okay.
All right, next up we have our great search that we're going to do this week.
Yes.
Which is, it's a Digi-Key doubleheader.
It is.
So we have the great search, which
There's
is
also a
brought to
cute
you
little
by...
Digi-Key logo on the back. They printed the logo.
Why don't you show that before
Oh,
we
it's
go
so
on to your
cute.
search?
Hold on, I didn't see that because it was at the very end. Look at that. It's so
Maybe.
small. Wait, it's upside down. This is like a Digi-Key logo for ants.
Yeah.
See that? Okay. Anyways, sorry. Back to the great search. What you were talking about.
All right,
Hi.
ready to do this?
Yes.
Okay.
Where in the world is that part I need? The great search with Digi-Key.
All right, the great search brought to you by Digi-Key and Adafruit every single week. Ladyada, what is the great search this week?
Okay, this week's great search is due to a part discontinuation. I have to find a replacement for our resistive touchscreen controllers. So we have lots of screens. Adafruit's kind of known for all the TFT screens that we stock. And when we have ones with resistive touchscreens, we like to put a resistive touchscreen controller driver on the back. Some chips have, multiple analog digital converters. You can kind of do the resistive touchscreen handling on chip. But, a resistive driver is not too expensive. And for boards like the Raspberry Pi, when we can connect a touchscreen to a Raspberry Pi, we add an I2C or SPI converter to read those analog values of the resistive touchscreen and convert them to like X, Y, and coordinates. So for many, many, many years, we have used the STMPE series. We started with the STMPE 610, and then we updated it to the STMPE 811. And we were using that for many years, and then it got discontinued, but we were still able to purchase a bunch of parts. But as of this week, we cannot get any more parts. They were really gone. We went through every backstock, every broker, everything. So the STMPE 811 is no more. So we have to find a replacement. And looking for a replacement, well, one thing I really liked about the STMPE series is it was both I2C and SPI. So it would be cool if I could find one of those. That said, If not, I'm willing to go with, one part for I2C and one part for SPI. I'm looking for something easy to use, and most importantly, I'm looking for something that already has Linux kernel drivers, because I don't want to have to write a driver for the resistive touchscreen. I really like it if it just magically worked when I connected up the chip and gave it a device tree overlay. So let's go to Digi-Key, and let's show the part that is sadly no more. It happens, you have to be ready for it. That's why you would buy stock. If you need product to last 10 years, you have to buy 10 years worth of stock, or you have to just be ready and willing to re-engineer it. Don't ever count on a part being forever. Even from large companies, they eventually stop. So this is the STMPE 811. So sad. A 4-wire resistive controller. It had this really nice thing. It was both I2C and SPI. So just for fun, let's see if there's any that are I2C and SPI within the touchscreen category. I don't care who it's by. I don't really care what package it is. Obviously, I'm not going to pick obsolete. I want it to be active. Voltage supply doesn't matter because it's going to be different, but as long as it covers 3.3. Oh, I do want surface mount, and the package doesn't matter. I'm not expecting to get something that's the same package. That's a lot to ask because there's not that many resistive touchscreen controllers. So there's a couple. So there's the this one's not active. So let's only look at active ones. So it looks like there's this BU21021. Nice symmetric name. This one looks pretty good, but it's in a BGA format, which I really, really don't want to deal with. So unfortunately, that one, I'm going to say no. So let's look at the BU2124. So it's not, too bad. The pricing is a little expensive. It's $2 for 1,000. Considering usually I can get a touchscreen controller for under $1. This is where it's how much do I want a chip that does both versus the price? In this case, I tend not to need both I2C and SPI at the same time. Again, for Raspberry Pi displays, I'm using SPI, or I use one or the other. I'm not switching between the two. Same with shields and stuff. I have a touchscreen shield. I'm using only one or the other. I don't switch between the two. So, you're wondering, how do I know if there's a Linux kernel driver? Well, I actually opened up, if you go to github.com and then go to Torvalds, Linux, Blobmaster, whatever, input touchscreen, this tells you all of the available touchscreen drivers. Are they any good? That's for me to find out later, but I can at least find out if there is some support in the Linux kernel for them. So in this case, I'm going to search for this part number and see if anything comes up. Unfortunately, nothing has come up. So I start deleting some characters. So it looks like the 21029 is supported. This is the 21024. So it might work, but it's not guaranteed. And let's see. There's here it is, the 21024. Okay, so this one is supported, so that's cool. So this is an option for me to look at, which is just nice and positive. Again, you have to be careful about your search because it's a -24, so you just delete characters off of the end when you do the search until you find one that's close, and then sometimes it also supports the variants. So yeah, that's what you got, the 029, 02324. So that's cool. So this is supported. The price is a little bit high, but I know that it's available. It's also only 8-bit, which I feel like I could get more bits for $2. But maybe, they're just like, hey, if you're desperate for something that does I2C and SPI, this is it. This is the only option you got. That's not BGA, and it still exists. All right, so let's go back and keep looking. So let's get rid of interface. And let's, so we still have active only. And now remember, I really don't want to deal with BGA. It's always, I'm not against it, but let's not, right? It's my preference. So let's look through all these packages and remove ones that I don't want. So DFN is okay. I don't want BGA or chip scale, or WLSCP, which is also chip scale. QFNs are okay. QSOPs are okay. SOPs are okay. I don't want CSP again, chip scale. I don't want QFN, that's okay. More QFN, SOP, QFN, no BGA, QFN, TSOPs. I'll go up to 32 TSOP, but 64 QFP is ridiculous. I'm not going to take that. That's too big. All right, so I got rid of the BGAs, so that at least I'm not going to get any parts that I'm totally unwilling to use. I'm also going to look at normally stocking, so I'm only looking at ones that are around. So to start, I'm actually going to look at. I'll tell you something just to watch out for. So normally I would search for like interface, but I noticed that there's like I2S here, and then some say serial, but when they say serial, they mean SPI. So I think I'm going to like I will acknowledge that there's this interface selector box, but I don't completely want to use it because I'm not sure what serial means in this case. It's kind of obscure. Is it UR? Is it SPI? You know, who knows? Like, why is I2S in there? So I'm going to leave that be. Next up, I'm going to, so there's nothing really else. All of these are within the voltage ranges I can use. I don't really care about the current supply or the operating temperature. Again, the packages are okay. Voltage reference, you know, I'll deal with it. I kind of don't want tube, but I'm not willing yet to say no tubes. So instead, I'm going to just do my classic search by price. And I see immediately, like, there's some super cheap ones up here. And I kind of like, oh, I've got the Rochester. Let me exclude the marketplace ones. So I look at only, because the marketplace are going to get the same thing, but sold under different names. So removing that, I'm only getting lots of TI parts. Looks like TI, Semtech, analog devices do a couple, but you know, the prices start getting really high again. It's like, you know, $4 per. Let me look at prices at 1,000 so I can honestly compare these. So yeah, basically, you know, there's all the parts that are like under $1 is going to be TI, and then Semtech comes in a little bit. All these are 12-bit, so that's kind of good. And then it looks like for my options, these are kind of different packages of the same part. See, it's like TSC 2046 and then IPWR, that's this TSOP, and then IPW, this is the non-reeled, and this is the QFN version. But it looks like the what's definitely popular here is this TSC 2046. It's very promising because, again, I want something that is inexpensive, reliable, and will be around for a long time, right? I want all three. So let's go here and let's search for TSC 2046. So it looks like the TSC 2046 is actually supported under the ADS 7846 driver, which is a driver even I've heard of. So that's a popular touchscreen controller, and it sounds like this is like the next generation, and it's register compatible, so you can use the same driver, which is nice. I like that. So this chip is going to be really good. And this one is SPI, and then down here you see I2C serial. This one is the TSC 2007. Oops. So this one is also supported. And it looks like there's a couple different options. It looks like you can do ADC. It can act as an I/O expander or something. Oh, weird. So these are two good options. Both are available in 16 TSOP. Kind of wondering if these are pin compatible. That'd be kind of neat. Let's see. It sounds like there's a couple families. There is a BGA version. There's a QFN version. Is there a TSOP version? Oh, weird. Huh. Okay. Maybe it's not actually available in TSOP. So it's available in QFN. So let's look at QFN here. And then let's pop back over here and download the TSC. Oh, sorry. I downloaded the wrong one. Okay, so this is the TSC 207. This is the I2C one, which has 2 address pins. Okay, sorry, this is the TSOP. And then let's download the 2046. Looks like this is from Burr Brown, which they got acquired a bit ago. Okay, so look, VCC, X plus X minus Y, BDD, and then ground, NC ground, VBAT aux. So this has like some more options. Aux, declock, SD. Okay, so it looks like it's a little bit compatible. Not completely. The IRQ changed. So they're not pin compatible, but they're same physical size. So, whatever. That's good for me. So these are the two options. And then, I actually went over to the TI website to check. Were there any touchscreen controllers that had both I2C and SPI? And the answer is no, there aren't. So, I kind of wanted that, couldn't get it, but I am really happy that I can get two touchscreens that are kind of from the same family, so hopefully they can share some of that driver code. One I2C, one SPI, same package, so, I might be able to, at least reuse the footprint somewhat. It's like the copper traces would be different, but the footprint of the part would be pretty similar. Left-hand side is the same, right-hand side would need to be rerouted. But that way I can maybe make breakouts for the same chip that would be I2C or SPI, and it would allow people to use resistive touch controllers with Linux, and then hopefully Arduino. There's probably drivers already existing, and then we'll write something in Python as well. So that's kind of going to be my choice for replacing the STMPE 811 is going to be this TSC 2046. Sounds cool. It's also I think the name of the next Blade Runner movie.
All right. That's a great search.
That's it.
Where in the world is that part I need? The great search with Digi-Key.
All right, 2 questions. Did you have a part number linked to the Keyswitch holder?
Oh, the socket? They're called Kailh switches.
Okay.
We'll have them in stock. They're not available from your common distributors. However, there's a lot of DIY mechanical keyboard sites, and they're available there.
Okay. Some folks answered this, but they want to know what's the barcode on the cut tape.
On the cut tape?
And someone said the first alphanumeric code is represented in the barcode. That code traces the piece of cut tape back to the original reel it came from.
That's cool. Thanks. I didn't know that.
That must be what it is.
Yeah, but that makes sense. Usually if you're doing, you want to track parts. We use barcodes to track our parts too.
Yeah. All right. People like the product development in real time here.
Yeah.
And maybe for a future one, USB hub controller.
Ooh, I'm making a breakout for one, and I'm gonna try it out, and then if it's good, I'll do it in the great search. It's good. That's a good suggestion. And there's some good USB hub chipsets that are available. They're not too expensive.
Someone says Genesys Logic, Genesys Logic is good.
Okay.
SMSC hubs are popular.
Okay.
Good to know.
Yeah. SMSC. Those are the microchip. Microchip purchased them.
All right. We'll
All right.
see everybody during the week. Keep staying safe. Tunnel light in it. We'll see everybody on Ask an Engineer this week. Show and Tell and Pedro are doing. We got JP doing the product showcase on Tuesday, workshop on Thursday, Scott doing deep dive on Friday.
Yeah.
And a whole bunch of videos and more all throughout the week. Thanks for supporting us. If you have time, you have an hour and a half. Go to our website, you'll see the banner, and there is
10%
a sale.
off. Yes,
So-
till the end of today, you have a little bit more than an hour.
All right.
And then we're going to shut off the code.
See everybody soon.
Thanks, everybody.